So it's late night at the shop, and this thing is not going to let me sleep. So we're going to do some diagnosing. Here we have to use all of our resources. From a suggestion from Eric and Keith, I did look on Identifix and I typed in P0606, and one of the confirmed fixes was replaced instrument panel fuse block. Now you might ask, what the heck does the instrument panel fuse block have to do with that main relay, loss of power, the computer? I don't know. So let's see. So, the most common fix is replacing the engine computer. Sure enough. But one of the fixes is instrument panel fuse block. Now, if we go to this case study and read about it, this is actually very recent, February 14th, 2017, on a Chevy Traverse, 2013 model year. Look at the description. The engine would set a P0606, and I would have a 69E, and the fuel pump also a P2534. The windshield seal was leaking water into the cabin, where it would run down and short the fuse block on the passenger side. And the confirmed fix is replace instrument panel fuse block. I don't know. The symptoms sound like exactly what we have. The same codes. He didn't say anything about the transmission, but the first time around, I don't think the transmission set a code either. So now we have to either go there, pour water on the car, see if it leaks on the fuse block, see if we can recreate it. But first, let's look at the wiring diagrams and see how the heck the system is tied into that instrument panel fuse block. Also, there's a TSB on covering this vehicle. It says floor wet under carpet, engine continues to run with key off, possible no crank, no start, communication loss, various electrical concerns, seal seam. Let's see here. Some customers may comment on any combination of the following conditions. Evidence of water leak on the right side A-pillar or on the right front floor. Electrical concerns. So, water dripping on the instrument panel electrical center, body electrical center, I think that's what it stands for. Inspect the right side A-pillar, windshield area, and water test for any leaks. It says inspect front drain hoses, ensure they're free of clogs or kinks. They give you a little schematic there. There's a sunroof drain hose. And then the fix is to reseal something under in the cowl area. This is like that Subaru Forester, right? So, okay, that's definitely worth having a look at. Now, this TSB actually was printed off by the initial dealer that they went to. Again, we have to keep everything in mind here, all the pieces of the puzzle. So, we could do a water leak test, but let's look at the wiring diagrams and see how this is tied into that instrument panel fuse block. So basically, we're trying to find a scenario of how we get where, it's a no crank. We set the 0606 code, and we lose power to our fuel pump control module and transmission. So right off the bat, we can see that the common denominator here is this ignition main relay. So it looks like we are losing power right here, which goes to our transmission fuse and our PCM ignition 10 amp fuse. Okay? Now, it could either be a load side issue, it could be a bad contact here, here. You know, this is a battery positive bus. It's a a main power feed that's in the under hood fuse block. Or it could be a control side issue. Now on the control side, the ground is G110. So again, we see our ignition main relay right here, and the control side is grounded right here through a splice in the underhood fuse block, down, 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 G110. Very curious to note, G110 also grounds our engine control module. Two main grounds there, and the automatic transmission assembly. Two main grounds there. So, what if we have an issue with this G110? That could definitely cause our relay to switch off. If we have bad grounds at the computer, that could definitely cause it to go haywire and set a processor code for sure. If we lose grounds at the automatic transmission, then also issues. So that's interesting to know that all these grounds are tied together at this G110. Keep that in mind. Okay, so back to our ignition main relay diagram. We know that this right here, I'm going to label that. This is G110. So constant ground, should be a constant ground right there. And the control side here comes from, well, two places. Either the ignition switch or the BCM. So you might ask, why can the BCM turn that leg on if the ignition switch is off? Well, that's for the remote start. So the body control module decides, when you press the key fob and the vehicle is locked and off, it can start the vehicle. Okay, so keep that in mind. And the previous time, the first time it acted up after our 45 days after it was here last time, the owner said she tried to start it with the remote start, and when that didn't work, she was like, uh-oh, there might be a problem. And then she got in the car, she tried to start it with the ignition switch. That didn't work either. Another piece of the puzzle. Okay? Keep that in mind. Now, with the ignition switch, if you try to start it, where does that power come from? So we're kind of backtracking from the control side of the relay through the BCM to this ignition switch to this power mode fuse S. Alright? And now we get to power distribution diagram. Again, there's our S, backtracking. We have a power mode 2 amp fuse in the instrument panel fuse block. So now we could potentially see how water intrusion into this fuse block could mess with the main ignition relay. Okay. Also, that same fuse is a power to the theft deterrent system. So, what if, I don't know, obviously this fuse isn't blown now since the truck starts fine, but, I mean, let's say you lose power here, then nothing would work. No remote start, no regular start. So that's how that is tied in. And if we continue up this tree, come to this R, and on the same tree we have powers to the BCM, and that comes from a main battery 150 amp fuse. So yeah, it's all tied together, and we could potentially have a problem in this instrument panel fuse block, which you would not even think about to begin with. Okay? So now we need to design an experiment of either A, recreate this problem, B, measure voltages, see what drops out. So let's think of something to do here. The truck is in the shop, it's kind of thawing out, it was cold outside. I got the wood burner going. We got scanners and scopes. So we have to get to the bottom of this because I want to get at least a couple hours of sleep tonight. Probably it'll still be more than Keith is getting because, man, that guy, he doesn't sleep. But anyways, let's get to it. Alright, we got this little plastic panel off. There is our fuse layout, and you can see 2 amp power mode fuse is right in the middle. Now I'm going to try to get you a shot of the fuse block here. There it is. Let's see. There you can see fuses. Now I'm going to do a very thorough visual inspection here and see if we can notice any signs of water intrusion. And if not, I'm going to pull that 2 amp power mode fuse and see what happens on the dash when we try to start this car. So, be right back. Alright guys, so if you look real close at the plastic right below the fuse box, you can almost see signs of water traces coming down. I think that's water traces. So I'm going to pull that fuse out, see what happens, but I think we're going to have to get to that fuse block, pop open the plastic cover, and look for green crusties. That's what we might have to do. So that fuse didn't look bad at all. Let's see what happens. Nothing. Hood open. Ice possible. So that's not it. Let me close the hood just for reference. So with that fuse out, the BCM actually set a B1380 device ignition accessory circuit short to ground or open. Interesting. And let's see here. And the theft deterrent system, I'll have to switch the key just a second. And there's a no-com with the theft deterrent system. So my theory of that fuse losing power, not correct. Let's pop it back in and check for codes. Alright, so with that fuse back in, our theft light is out, and we should be able to communicate with this theft deterrent module. No codes present. It should fire right up. No problems. Okay. Turn the lights off here. So make sure we don't have any more codes in the BCM. Swap the key out. So no codes present currently in the BCM. Alright. I think the next step is tear this fuse block out and look for green crusties. I mean, I don't have any other ideas of how to recreate this fault, and the symptoms sound identical to what we have, and we do see water traces, so that's the direction we're going in right now. To get this fuse box out, I decided to peel back the carpet a little bit, and we do see some signs of moisture right there. Right now it's a little iced, but once it thaws out, we might see another Subaru Forester, right? Try and get this carpet back a little bit. Okay. So there's some moisture there. I want to see if I see any signs of water leaks. Maybe a little bit there. I don't know about down there. I'm gonna keep digging here. Guys, we might be on the right track. There's quite a bit of moisture on this carpet. So we're gonna keep peeling it back, see what we find. Well, this is getting exciting. Come in here. What do is squeeze the foam, right? Come on, carpet, stay up. I'm gonna try to get you a shot of this. There's water right there. Not supposed to be there. Subaru Forester. Well, we can always do a water leak test, but we gotta get that fuse box out and see if it's damaged. I mean, this is moldy. It looks like the carpet or the foam. So maybe that TSB and that tip from Identifix, maybe they're spot on. I hope. So I'm trying to get this fuse block out. I unplugged these two top connectors, and what do we see? Bum, 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 the green crusties. All right. We're getting somewhere. Now if we identify, oh, this is looking pretty bad, guys. Looking pretty bad. If the whole fuse box is filled with water, we're in for a treat. I'm surprised this isn't throwing more codes, but we still have to figure out what's going on exactly, which circuit's affected, see if we can recreate this problem. Because if we see green crusties, it doesn't necessarily mean that, well, it means we have a problem, but we still have to address the customer's concern. So I'm going to try to get the fuse box out, see which circuits are affected, how it ties into everything, and we'll go from there. Alright, I got the bottom big bulk connector unhooked, and that doesn't look too bad. So let's try to get the rest of this fuse block out of here. See if the harness gives us enough room. I didn't know fuse boxes are supposed to have water in them. Uh-oh. Let's take her apart. You got green crusties on the top two connectors for sure. All those relays look like they might have some green crusties on the legs. But that lady right there might be your problem. It might. It's pretty heavy. Wonder if half of it's water. Oh man. I don't even know how this thing comes apart. But we'll figure it out. Alright guys, I think we're almost done with this GMC Acadia. I'm satisfying my curiosity. I have these connectors at the fuse block printed out, and I traced every single pin on here and there. Anyways, what I noticed on connector X2, it's a blue 16 pin, these two pins right here were shorted together. Now let's see that on the connector itself. So here's the worst one. See those two adjacent pins? See the big black mark right there? It's all wet. So it's a pink and a red with a white. So those two wires, let's say, hypothetically, are shorted. You can also see it right there. Those two pins, a lot of black in between them. So let's say it was almost like a jumper between them. What could happen if there's a jumper? So those two pins, pin 15 and 16 on connector X2. What are pins 15 and 16? Well, let's see. Pin 15 is a constant power, and it's a 10 amp fuse, and that is, let's see here, where's our main power distribution diagram? Alright, X2, pin 15, constant power from this in-adv power LED fuse. So it comes out. So what if that is shorted to pin 16, which is supposed to be ignition voltage, via airbag 10 amp underhood to instrument cluster. And that guy is right here. Pin 16, connector X2 at the fuse block instrument panel. So that right there is part of this tree, which is fed by the ignition main relay. Aha! So now, let's say we have positive, constant battery power being fed into pin 16 when it's not supposed to be. What is that going to do? That's going to power up this trans PCM ignition 10 amp. Is going to power up our fuel pump control module and the engine control module. So what does the ECM think when we have power right here when there isn't supposed to be power, when the ignition switch is off? I mean, isn't that crazy? So this relay supposedly is off, yet we have power here, here. We have, so let's say we have B plus, or it's not battery voltage, but some voltage. Interesting, right? Very, very interesting. So I almost want to put, let's say, a resistor between pins 15 and 16 on that connector and see if we can reproduce this problem. I think that would be really neat, at least for the video. So, let's say our ignition switch is in the off position. The BCM, well, the BCM is also, might be confused, but if this relay is not being switched on, and we do have power here, here, and here, then, I don't know, potentially we could set that code. And if this voltage isn't high enough, let's say it's somewhere in between, that's when our problem occurs, I think. So how about we put in a resistor, a variable resistor between these pins, and see if we can dial it in, and I don't know, hopefully not fry the computer. I don't know if we want to go that far, but just to prove the theory, I want to make this thing act up, and I want to know why it's doing what it's doing. So I don't think this fuse box is meant to be taken apart I really hope I can get all these pins back in there, because if I can't, then this truck is not going anywhere. But there is a lot of water in there, so we can at least blow it out and do our controlled experiment of shorting those pins. Ugh. Alright guys, so here's the fun part. We are going to simulate a short between those two wires. And not a complete short. We are going to go through a decade box. This is courtesy of Keith DeFazio. He had a spare one lying around, so gave it to me. I fixed it up, cleaned it all up, so it works great. So the circuit is, we're going to go from that power wire, constant power, red with a white, through our decade box, through a certain resistance, and then out on this black lead into that pink ignition feed. And if you remember, on pin 16, this will backfeed through the airbag fuse and power up all of our, whatever, computer, transmission, etc. So I want to know at what voltage level this car will act up, and hopefully we can reproduce that, reduced engine power, etc. Now the scope is hooked up to that pink wire, so it's piggybacked. So when we plug in, right now I have it set to like 80,000 ohms, go 90,000 ohms. You plug it in, and our voltage goes to 0.4 volts. Interesting. And if we drop the resistance down, so that's 80,000, 70,000, 60,000, and our voltage will creep up. So let's try to start the vehicle now, make sure it runs normally. So I didn't break the fuse box. So let's turn it off, turn the key back on.
Welcome to your message of the month for February 2017. My name is Chris Lark.
Let's turn that off. So here's our ignition voltage on that main relay. You shut the key off, it drops right down. So that's the way the main relay is supposed to work. So with the key on, we're at 12 volts. Let's reset all the codes and see if we can get those codes back. So now we are safe to, let's see, current codes, no codes, history codes. Let's clear those out. Yep. Okay. No codes. Okay, no codes in the BCM. Let's get out of here. Let's go to, well, I guess we can go in order. Airbag. We still have the K21 key connected. Oh, no, that's the K17 key. Let's see, exit out of that. ABS. Codes. Display codes. Current codes. No codes present currently. History. And obviously we lost comm with the BCM by pulling that fuse, so let's reset those. Yep. Okay. No codes present. Excellent. Let's go back to our transmission. K17 key. Codes. Display codes. So the 2534. Let's delete that one. Okay. No codes present. Excellent. And finally, in our engine menu, let's see what we have in there right now. No codes present. So I guess we already deleted those. Alright, so now, the fun part. So let's turn the key off. Go back to our scope. So now we're at 0.4 volts. Let's start raising this voltage and see what happens. So half a volt, 0.5, 0.6, 0.7. Okay. Let's see if the truck starts normally. Looks good. Make sure we didn't set any codes. No codes present. Alright, so that's how our experiment's going to go. So let's see, key off. Now we're at 0.7 volts. I'm going to decrease the resistance. We're at 1 volt. One 1.4. One 1.45, 1.6, 1.7, 2.3. So remember, we had 2.4 volts on our freeze frame, so maybe this will be enough. Let's see. Key on. Still starts up. Okay. Key off. And I have an amp meter right here just in case you don't want to go over voltage here. Let's see. You see that? Something just happened there. 2.3 volts. Let's see. Still starts up fine. Okay. Three volts right now. How high should we ramp this up? Four volts went down to 2.6. There's 0.2 amps going through our decade box. I just turned up the hundreds resistance just in case. Let's see. So 900 ohms, 2.7, 2.8, 3.0, Let's bump it up. 4.4. Ooh, something just happened. Something activated. And let's see. Check engine lights on. Let's see what that's all about. Ah, here's where you can't shut the truck off with the key. That's one of the complaints in that TSB. So if we turn up our resistance, we can shut the truck off. Let's see what codes we set. Interesting, interesting. See, scanner, engine, continue. $1682. Fuel pump control module requested illumination. Let's see what that's all about. Fuel pump. Nice. Yes. Yes. So with the 2534 set in the fuel pump control module, that's exactly what the symptom was. That's fantastic. So we recreated that just by shorting those pins out with a controlled resistance. That's exactly what's going on. That makes my day. I'm not sure where this 1682 came from. Let's see here. Let's look up a 1682 and check this out. Check engine lights, very dim due to our resistance. If we ramp this up, that'll go away. So let's look up the 1682 just for kicks. So the ignition 1 switch circuit 2, the 1682 right there, that code does make sense. And we still haven't recreated the 606. Well, I don't know. Should we keep trying? Alright guys, I'm going to call it a night. I guess we got as far as we could here. We still have to determine where exactly the water is coming from. It's either sunroof drains or the cowl leak like the TSB said. So, I don't know, if I find the water leak, it'll be a part 5 or whatever, but obviously this needs to be fixed, and that fuse block should be replaced or dried out really well. I don't know, or those pins cleaned up. Yeah, we'll see. I'll get some prices and we'll fix her up good. Alright guys, let's wrap up this Acadia problem child case study. So I talked to the owners, explained to them what was going on with the water intrusion and the corrosion on the fuse box and how it was all related to their symptoms of the no crank, no start. So I told them that sure, we can put in a new fuse box, but we need to address this water leak. And another new piece of information for me was the owner said that she had the windshield replaced last year, and now when she takes it to a car wash, she can see water dripping down from the front, the passenger side dash. I'm like, well, that could be the source of the water intrusion. It could be a bad windshield installation. But we also have that TSB that shows that the cowl needs to be resealed. And I just told her I'm not equipped to deal with water leaks or windshield sealing or any of that stuff. And honestly, you guys have seen the Subaru Forester water leak series, and I just don't want to get into that. Honestly, you know, I'm an electrical specialist, not a body guy. So I told them to fix the problem for good. They need to address the water leak, dry the carpets out, and then at that point replace the fuse box. So for now, what I offered was, since you know, we took the fuse box apart, we kind of blew most of the water out. We saw that the corrosion was confined to those top two connectors. What I said I'm going to do is just clean those up the best I can, make sure the truck runs fine, clear all the codes out, and just let the fuse box kind of hang out of the way so it doesn't get water on it. Hopefully we just kind of, you know, let it chill here, because that will need to be replaced soon anyways. I just wanted to get it away from the firewall there. So we'll do that, button her back up, and you know, send them on their way. So I really appreciate you guys watching. Let me know in the comments what you think of this whole debacle. It was one of those, you know, I guess technically it was a comeback, but not for reasons, you know, I don't feel like I did anything wrong, or I definitely did my best and used all the information I had, and that is how it goes sometimes in this field. So appreciate you guys watching. I'll see you next time. Bye bye.